Yes, dear student, now in last video I told you that there exists a pressure difference across curved surfaces and concave side has greater pressure than convex side. So we will try to find here that excess pressure. This is small p here in terms of radius and surface tension. So let in figure we have a drop of liquid of surface tension T, whose radius is capital R, whose radius is capital R. Now, due to surface tension, molecules of liquid on surface experiences an inward force. So, to maintain the shape, there exists excess pressure small p. Here this p outside pressure equal to inside for equilibrium. Actually for equilibrium p plus this is extra pressure. This p is balanced by this. This p here small p maintain the shape. Now if due to excess pressure p due to excess pressure P, the radius of drop increases by delta R. Initially it was R and now it becomes R plus delta R, where delta R is so small that small p does not change. So work done in expanding the drop W is equal to actually force into डिस्टेंस डेल्टा आर होगा. बट व्हाट इज फोर्स? प्रेशर इक्वल टू फोर्स अपॉन एरिया. तो फोर्स इक्वल टू प्रेशर इंटू एरिया. तो स्मॉल p इंटू 4 पाई r प्लस डेल्टा आर होल स्क्वायर. नहीं सॉरी 4 पाई आर स्क्वायर इंटू डेल्टा आर. This is the work done. Actually, 4 pi r square is this area of this. This area here is 4 pi r square and pressure P, excess pressure P, W. Due to expansion, increase in the surface area. Due to increase of radius, increase in surface area, that will be 4 pi r plus delta r whole square minus r square, which is equal to 4 pi bracket r square plus 2r delta r और प्लस डेल्टा आर स्क्वायर और माइनस आर स्क्वायर. डेल्टा आर स्क्वायर नेगेटिव इज होल बिकॉज डेल्टा आर इज होल. सिंस डेल्टा आर स्क्वायर इज नेग्लिजिबल स्मॉल, so delta A equal to this cancel, this only left 4 pi into 2r delta r. 2r delta r square यानी कि 8 pi r delta r square, and hence work done T into delta A, T surface tension. So it is 8 pi r into delta r square into T, equation 2. This work done is on the drop. Comparing equation 1 and 2. Comparing 1 and 2, what do we get? P into 4 pi r delta r is equal to 8 pi it is r is only here, sorry, delta r है यहाँ ये डेल्टा r और ये है आर स्क्वायर. सॉरी यहाँ आर स्क्वायर, सॉरी वो एक्चुअली वो आर प्लस डेल्टा आर होल स्क्वायर खोलना ना, तो वी गेट आर स्क्वायर प्लस 2r डेल्टा ए बी प्लस डेल्टा आर स्क्वायर. तो यहाँ मिस्टेक होगा हमसे, मेहनत कर लीजिएगा. 8 पाई आर डेल्टा आर into T, delta R into T. So here delta R cancel 4 to the, so P comes out to be 2T upon R square upon R only. So this is the pressure difference across curved surface. Concave side has this pressure. Now if we take air bubble inside a liquid, if we take air bubble inside a liquid, Suppose here is container and there is a liquid and this is air bubble here. You might have seen the soap bubbles in soap solution when we wash clothes. Air bubbles are soap in soap solution. Air bubbles are formed, they expand and then they break. Why? Because of this pressure difference. Here this radius R, so it becomes suppose R plus delta R. So same way, let tension of this liquid be T. So pressure difference P, extra pressure P, due to that is increasing, so we work done. And on the same way we proceed, that W is equal to P into 4 pi R square into delta R. Force into distance, 4 pi R square. And then again work done due to surface tension increase in area, 4 pi R plus delta R whole square minus R square into T. So again the 4 pi, 4 pi this R square plus 2R delta R plus delta R square minus R square into T. So this is negligible and this cancel. So we get it as 8 pi R, 8 pi R, 8 pi R delta R into T. Or comparing these two equations, we get the same value, P equal to T by R. Whether it is air bubble inside solution of a liquid or it is a drop of liquid, pressure difference same. Here this surface of this outside remain in contact with liquid. Now if it is soap bubble in air, if there is a soap bubble in air, either air, यहाँ भी air, so that way here when due to pressure difference it increases. Actually inside surface and outside surface increases. तो यह डेल्टा A जो होगा वो 4 pi R plus delta R whole square minus 4 pi R square into 2 होगा वो, क्योंकि one surface increase outside and this is inside. And then there work done क्या हो जाएगा W delta A into T. So how much will be left? Twice of 4 pi R delta R. यानी 4 pi R, यहाँ 8 होगा ना, सॉरी, ठीक है भाई. और उधर वर्डन वो ड्यू टू इंक्रीज इन वॉल्यूम वो क्या होगा P इंटू 4 pi R स्क्वायर इंटू डेल्टा. तो कंपेयर करेंगे तो ये P विल कम आउट 4T by R. Inside soap bubble there is pressure of 4T by R. If there exists a soap bubble in air, then pressure difference, excess pressure on concave side is 4T by R. So with the help of this, we will come to so many topics. Capillarity, you know. I will take it. Capillarity, यार बोर्ड को क्या होगा? Capillarity. Very important point here. Topic. Capillarity. Capillary tubes are the tube of narrow bore of the diameter of millimeter size. मिलीमीटर साइज ट्यूब है, दिस कॉल्ड कैपिलरी, ग्लास ट्यूब लेते हैं, सो दैट लिक्विड इनसाइड इज विजिबल। इफ वी डिप इन वाटर और एनी लिक्विड लाइक वाटर विच वेट, तो लिक्विड राइजेज अप, लिक्विड से ऊपर जाता है फ्रॉम फ्री सरफेस। ये फ्री सरफेस है, दिस हाइट एच इज कॉल्ड कैपिलरी राइज, capillary rise. When we dip a narrow bore tube in a liquid, liquid rises. But if in case of other liquid like mercury, it dips down. Mercury ऐसा convection में आता है, that dips down. So this phenomena is called capillarity. Rise or fall of liquid inside a narrow tube above or below the free surface is called capillarity. Due to capillarity, we observe many things. When you place ink pen on blotting paper, the ink gets spread in the whole blotting paper. Initially, in the early time, we used to write ink pen, and sometimes extra ink gets spread on the paper. So to observe that, we use blotting paper. Now you can see in chemistry lab that filter paper. You take filter paper, put your ink pen, that spread it on this. It is because of this capillarity. Kerosene oil in a lamp rises through the क्या बोलते इसको हमें, ये यहाँ पर ऑयल भरा हुआ है, ये उसका, तो यह फ्लेम इज ऑब्टेन्ड बिकॉज kerosene oil keep on rising to this. I'm sorry for coming. Similarly, in melted wax, in candle of wax, when it burns, keep on rising because of capillary. Plants need water in their leaves. In the stem of plants, there are innumerable capillaries. Through them, water rises up. The leaf of the plants release extra water through leaves, and a vacuum is created. That vacuum helps the water to rise up to the top. Because trees are very of large height, so to such height we have to raise water. Only surface tension does not help. So these are some examples of capillarity. When we give water to the farmer, give the water to his crop, then if there is no crop, only it was given water to make the earth soft. Then if it becomes dry, then farmer actually used a roller on that. Why the roller is used? Because when the earth start being drying, so small capillaries are formed. Through those capillaries, the whole moisture will evaporate. To avoid the evaporation of moisture, the capillaries are to be broken. So rollers are used. If he has no time to plow the field, खेत जोतना है, टाइम नहीं है, तो क्या करते हैं, रोलर चलाते हैं खेत में रोलर, तो उससे कैपिलरी टूट जाती हैं। सिमिलरली जब क्रॉप होती हैं तो देव उसको उसकी गुड़ाई करते हैं, उसको जोतते हैं, ताकि जो कैपिलरी बने वो पानी एवोपरेट ना हो। दीज आर द सम एग्जांपल्स ऑफ कैपिलरी। आई विल टेक इन नेक्स्ट वीडियो द कैपिलरी राइज हियर, है ना, कितना होगा ये राइज, दैट इज कॉल्ड कैपिलरी राइज। I will take in next video. Thank you.